2, started the recording. All right, so let's get into what we're doing. Hey, Daniel, the question for today is going to be, what is your favorite game, video game, board game, card game, whatever. So you can just put that in the chat. I put Tony Hawk Pro Skater Underground for mine. I like it because it has a story, and then Tony Hawk Underground 2 was, I thought it was bad. I didn't like the story at all. Yeah. Let's see. In here, we'll get this going. So geometry. And we finished transformation and congruent. So now we're going to talk about all that stuff that we learned about congruence, and now we're going to apply it to triangles. The activity for this unit's a little rough. So I might put a video out on Friday just talking about the activity. Maybe go into it a little bit today, but I think I might put a video on Friday talking about how to do the activity because it is pretty hard. Even if I have to like show how to do it, I think that'll help you guys out more because some of those activities I have to end up doing with other students in the appointments. So in this lesson, we're going to explain the criteria for triangle congruent. So we're going to say what it takes for a triangle to be congruent. We're going to talk about what it means to be angle side angle. And these kind of, the way the things are listed goes on what aspect we're talking about. So let me turn on my pen here real quick. Ugh. I forget I have to turn my pen on like every single time. Yeah, that's fine. All right. There we go. So, for example, it would help if I had my tablet out. I'm like grabbing my pen, and then I'm like, there's nothing for me to write with. This real quick. Now's a good time for you guys to answer what your favorite game is in the chat if you haven't yet. All right. There we go. Oops. All right. So when it's talking about this, for example, if it's talking about angle side angle, let's say we have this triangle and we have another triangle. And we know that these two angles are congruent. Not necessarily all to each other. Like it's just saying that these two angles are congruent and these two angles are congruent. And we also have an angle in the middle that's congruent to each other. So that's if you see one of these marks, it just means that the ones with one mark are congruent. If you see it with two marks, that means all the ones with two marks are congruent. And the same thing with these. If you see a double mark and a double mark, that means those are congruent. But when it's talking about angle side angle, it's saying that the side is in the middle of two congruent angles. When it talks about side angle side, if we have two triangles, it's talking about two angles or two sides that are congruent with a congruent angle in the middle. So side, that one's probably the most obvious. That it has three correspondingly congruent sides. Corresponding meaning that you can like move it over to here. So we talked about how congruency just means all you have to do is rigid motion to make them congruent. So we're going to talk about how this applies to triangles. So the idea here, they're doing real life things. So if you ever want to know how we're using this in real life, always read the introductions are really useful. So this one's talking about a glass maker in a pinball machine and how he wants to make it congruent. So obviously, if you're making the same pinball machine over and over again, you really want to make sure it's congruent, especially in the restoration job. So always read these. These are interesting. If I hear all the time, like in my pre-calculus class, I had someone going like, "When are we going to use trigonometry in real life?" And I'm like, "Well, have you ever played a video game where someone pushes you this way and also pushes you this way? Don't you ever want to know how fast you're going this way?" Um, you might not want to know, but when you're calculating things in video games, somebody has to program how fast you're going that way based on forces going this way and this way. So that's where trig comes into play in real life. So if you guys ever are curious when you would use this in real life, those introductions are cool. You can always ask me too. I don't mind answering. So we're going to use our GeoGebra. Okay, I guess they just gave us a general GeoGebra. I'm used to them doing. So create a triangle of your choice, measure two angles and the side in the middle, record the measurements on this table. Okay, so what we're gonna do here is I'm gonna do this. I'm just gonna do polygon. Don't do regular polygon because that's just gonna ask you like, all right, well, how you're gonna make all the sides equal. We're gonna do polygon. So we're gonna 1, 2, 3, and then go back to the first one. It'll make a triangle for us. And we're going to measure our angles. So again, you want to do this counterclockwise. So by that, I mean we have to, if we're measuring this angle, for example, we have to measure it counterclockwise. So we have to go this way. So when we measure this angle, we have to go boom, boom. Oops, did this wrong. I did clockwise. Counterclockwise. I always forget. A clock goes this way. So counterclockwise would be going the opposite way. I even said it and I still messed it up. This GeoGebra is very picky. I wish you could just somehow do this better to make it measure it. But okay, so there's that angle. Then I'm going to measure this angle. So I want to go counterclockwise. So clock goes this way. So I want to go this way. So when I measure this angle, I want to go from C to A. So if I want to measure angle C, I want to go from A to B. And this is just like a tool. If on like a test or something, you would put like angle BCA, I'm not going to assume it's this big angle over here. I'm going to know which angle you're talking about. It's just how the computer wants it, just in case you want an inside angle or an outside angle. You can move these over here. Oh, did I measure this twice? I didn't mean to measure it twice. Okay. There we go. And then you can just record these, but they only wanted two angles. So I think I kind of overdid it. So I'm going to measure my angle A and my angle B. Admentum wants you to measure the whole thing, but since it's a triangle, I don't care if you just say angle A. They want you to go like angle B, A, C, for example. I don't care if it's just angle A. I know what you're talking about. Here, we're going to measure angle B. And all right, so I have 83.81, so 83.81. Over here, I'm going to put 59.15. And we want the line segment. So what we would do is we go to our measuring tools, distance or length. You could do click A and B, and that'll give you that. Or what you can do is you can literally just click the line and it knows that you're asking about the line segment. So I'm going to put 3.44, and that's the side inside this. So normally, since it's a line segment, we want to put that line on top. Where's, oh, there we go. If you don't, I don't mind because it's just saying the distance from A to B would be this. So if you say AB equals 3.44, that's what it is. When you say AB equals 3.44, that's saying this line. Doesn't really matter in this case. Technically, they want to see this. You'll see it written like that, though. All right, so now keep the triangle. So in a different place on the grid, draw a new line segment with the same recorded segment. So we're going to do the same line. This will be easier if you draw a segment parallel or perpendicular. So what I would do is I would draw a segment with a given length just to make this easier. So what you do is you go here and you're going to say given length, so 3.44. This one is guaranteed to be the same length. And since they're like, hey, oops, I clicked the spot. Since they say, hey, try to make it parallel or perpendicular, I'm going to try to make it look a little bit the same. So it looks kind of parallel. Doesn't have to be exact. At the end point of the new segment, create an angle with the given size. So what I'm going to do is I want to create an angle that's the same as this. I'm going to pretend that my D is the same as my A. This also makes it easier whenever you're making these because there's one of these in the activity. If you're doing A, B, C, you should make it respond where D is the same part as A, E is the same thing as B, which is what I did here, and F, which we don't have yet, should be the same part as our C. So similar, it just makes it easier when you're looking at it visually. So when we're doing this, what I'm going to do is I'm going to go to create an angle with a given size, go from, I'm going to click this point. Oops. This to this. Why is it not working? Oh my gosh. I'm sorry, guys. Hold on. Okay, cool. So the reason why I clicked E to D is the angle is going to come out this way or this way. And it's going to ask you, do you want it clockwise or counterclockwise? When I'm looking at this, I'm like, okay, so it's going this way. So I want my angle to be counterclockwise. So it's already on counterclockwise. And then what I'm going to do here is I'm just going to make the angle the same as my angle A. 83. Since angle D was the last one I did, it makes the angle right here. So that's all we're doing. And then what I'm going to do, the next part, if we read the instructions, it says you've created an angle. So now it wants us to make a ray. So making a ray is simple. We just go to this part, we click ray, we click our angle D, and then we click this point right here. And if you notice, it kind of snaps into place very nicely. If your mouse is really close to that, it just snaps in there. So there's our ray. Now, on the next part of the instructions, we have to make an angle at the other endpoint. So it says each endpoint. So we have to do this for both. So I'm going to go back, erase that. I'm going to go over here, angle at a given size. Now I want it to be my angle E. So I'm going to go from D to E. And I want this to be the same as my angle B. So I'm just going to copy that down. 59.15. Oops. That was the part I forgot to do. I forgot to mention if it was clockwise or counterclockwise. Give me a second here. Boom, boom. And if I look here, the line that I'm talking about is this line right here. So if I look at my angle, I actually want a clockwise angle. So that's what came out the wrong way. I wanted it clockwise. I wanted it to go with a clock. So just remember, picture a clock. 12's over here and 6 is over here. So the clock moves this way. So I wanted that clockwise. And then I have this. So now I'm going to do another ray. Click here, go to ray, boom, and I'll snap into place right there. Boom. Cool. So I have this new polygon right here. Oh, I forgot to mark it. You're going to click point, and you're going to mark this point right here. So the beauty of this, the way I did it, it goes D, E, F, and that should correlate with this. It's a little off because this line wasn't perfectly parallel, but that's fine. So if you want to do mark it as a polygon, this will let you kind of move it if you need to move it. So if you need to move this polygon, instead of moving one of the points, it's going to move all 3 points, not just one. So that's the purpose of this. I know you're like, well, what's the difference? It was already a shape. This, if I put like moving it, it will let me move it. So let's see what else the instructions make me do. Place a point, finish by copying the triangle, 3 points you created. So that's exactly what I did already. Place a point in the intersection. I already did that. You should now have your triangles. Notice the size and shape. So as always, what we're going to do is we are going to share this. So save your thing, put your name. I should be able to see it with your account anyways, but your name kind of just makes it a little more official, I guess. So give me a second here. And we are going to click save. Oh, I didn't mean to click save. Share. Is it not doing it? Okay, it's saving. Where's the link? Oh, there we go. Copy link. That was weird. As of right now, I haven't heard your teachers complaining too much, but if they do want an image, what you can do is you can click export image, download it, save it wherever you have. I save mine to the download folder. And then what you can do is go to insert image from computer. Mine's is already at download, so you might have to like find it yourself, but mine's is already here. So I'm going to click that. Boom. Saves it up and boom. So having both is good. It'll have your image and it'll have your link, so we can verify that it was you who did it. So translations, rotation, reflections, preserve links, map the points copied. So I'm gonna try to describe what I'm doing here. Again, I don't want you to be very specific because these are very exact movements. So for example, the first thing I notice is, okay, it's a little off, so I might have to rotate it. So what I'm going to do is I'm going to put a point right here just in anticipation for rotating. I don't know if I'm going to have to rotate. Well, I know I'm going to have to rotate it. It's not parallel. But first thing I want to do is I want to translate it. So I'm going to go here and I'm going, here. This is how these are all your transformations, reflections, rotations, translations, and dilations. All of your transformations that you need are going to be in this little dot right here. So first I'm going to translate by vector. So I'm just going to click this. If you guys are using the touchpad, make sure you click it with one finger, and with your other finger, you're going to drag this over. And I'm going to try to match up my E and my B. You could match up other points, like I could match up my C and my F, for example. But I'm going to try to do it with matching my E and my B. So I got that. Next, what I want to do is I want to rotate it because it looks like it is overlapping, but it's off by like a little bit. So I'm going to rotate this. So I'm going to rotate this shape. So I'm clicking the shape. This is why we made it a polygon about this point. And I don't know how far I want to rotate it. I know I want to go this way, or let me use my pen. I want to go this way a little bit. Or actually, I'm trying to see how much I want to rotate it. Oh, I wouldn't want. Give me a second, guys. I'm sorry. I don't want to rotate it about this point. I'm sorry. Because I matched it here, I want this point to stay the same, but I want all the other points to change. So when I rotate this, I was like, this isn't going to work. When I rotate this, I want it to rotate about point E. And you're going to kind of have to guess your angle a little bit. So I want it to rotate a little bit like that. I want it to rotate clockwise. Because if I did this, it would be clockwise. So first of all, I'm going to rotate it clockwise. I'm going to try rotating it very little at first. So I'm going to try like 5 degrees. See if that works. Really close. Really, really close. I went a little extra. So you can see that I'm a little off. So I'm going to undo that. I'm going to try rotating again about this point because I want this point to be the same. So I'm going to try 4 degrees. Oops, I did it counterclockwise. Great. I want it clockwise, 4 degrees. That looks dead on. It might be like if I zoomed in and got really nitpicky, it's like barely there. But I mean, also if I look far away, it's like, oh, perfect. So I would say that's matching for our purposes. So you might not have it exactly. That's fine. To be honest, we already know it's going to match up. So what I would do is I would say translated. So translated, and the way I translated it was left. Uh, translated left. I might have done up a little bit, but I can't really see that. And it's like, or what you can do, actually, this is better. Write it like this translated so that I did it the way I did it, so that point E lined up with point B. You guys might have it uh, point D to point A or whatever. And then I've put rotated about point B. Slash B if we want to get fancy, but we rotate about point E. And then we were able to overlap it. So that's all we did, or that's all I did. You guys might do it differently. You guys might rotate it first and then translate it however you guys want to do it. The triangle you created in question 2 should collide with the original one. Explain it, copy and paste your image. So what does this mean in terms of congruency and rigid motions? So this means, so if a triangle has a, okay, cool. Based on the, oh, okay, so blah, blah, blah. We're going to talk about what I was going to write later. So what does this mean if they coincide perfectly? So they did coincide perfectly. So what we're going to say is the triangles overlap. I'm not going to say perfectly because I guess it is a little off. Overlap. So they overlap. We know they're going to do perfectly. It's just really hard to do the rotation. So what I'm going to say is the triangles overlapped. After rigid motion. So this means that the triangles are congruent because congruent means you can do rigid motion to make them overlap. So what does this mean? What does this activity mean as far as triangles with that minimum same size and shape? So this means if we did a regular triangle, what this means is that any triangle, because we made up our own triangle, so it's very weird that we would find one that works perfectly. This means that any triangle with a congruent side to another that is in between two corresponding congruent angles are congruent. So this is a lot of words. Let me break it down for you guys so you guys can say it in your own words if you guys want to say it a lot easier. So what this means is if we have a side that's congruent to another side in another triangle that is inside these two angles that are also congruent, then this triangle has to be congruent to that triangle. That's what I'm saying, basically. You guys can say it in your own words, but if you guys need to know these words, you guys should know these words. Congruent means same size and shape. Corresponding, that means that these two angles are corresponding. I can move this angle over to here and they would correspond with each other. Same thing about these. These two angles, because of the relationship here, I would say that these two angles correspond to each other. So corresponding and congruent, like I said, same size or shape. And the reason why I said are congruent is because what was I talking about? I was talking about triangles. Two, blah, 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 with a congruent side in between two corresponding triangles. Oh, I never finished talking about the other triangles. So that is bad English on my part. To another triangle, they are congruent. So I'm just saying that. So that was just bad English on my part. Always reread your sentences because I had all the parts correct, but the rest was a little different. Is this making sense so far, guys? I know there's like a lot of words, but does that kind of make sense what I'm talking about? Did I lose you guys? Okay, cool. All right, so moving on to the next one. I really hate how Admentum does this. So this just says that exactly what I said, basically. If you have an angle or a side in the middle of two corresponding congruent angles to another triangle, that means these two triangles are congruent. So that's what that activity was trying to prove to us. So now this is saying two corresponding angles. Oh, they call it an included side. So the reason why it's called an included side, I knew there was a word for it. I always called it in between those two angles. Included means that it's in the middle of these two angles. So blah, blah, blah. So two corresponding angles and the concluded side are congruent. Which statement is true regarding the triangles? That means the both triangles are congruent. It doesn't mean that they're equilateral because you can have triangles like this. These are congruent, but obviously they're not equilateral. Actually, I drew them really bad, so they don't even look congruent. They're not necessarily isosceles, because isosceles means that these two sides have to be equal to each other. So, not necessarily. At least one of the sides is a right angle? No, because the one I drew wasn't, none of the sides were a right angle. So those are just random things there. I think this is a weird question to ask because it's like, well, yeah, we just learned that they're congruent. So side, angle, side property. So this means that we have two corresponding congruent sides with an included angle. So it's kind of like the opposite of what we just said. Instead of the angles having an included side, we're going to have sides with an included angle. So we're going to create a random triangle again. So I always use the polygon because it kind of doesn't make any sense. It kind of doesn't make any sense making your points and then making your polygon. So I'm just going to make the polygon from the beginning. And now what it wants us to do, let me get rid of this. Now what it wants us to do is measure the sides. So I'm going to use my little measuring tool here. I'm going to go distance or length. I'm going to measure this side and this side. And the included angle I want to measure is angle A. So what I'm going to do here, I always want to go counterclockwise. So that means I want to go from C to B if I want to include angle A. So I'm going to go to my measuring tool. I'm going to go C, A. That was counterclockwise. Oh, counterclockwise this way. From your starting point to your end point has to be counterclockwise. If you guys are having trouble with this, don't worry. A lot of students are. As you can see, I'm still having trouble with it. So it's a lot of trial and error. Luckily, there's an undo button. Let's move this angle so I can see it better. And I measured it twice. I don't know what happened there. Okay. All right. So now let's measure our lengths. So I'm going to talk about AB and AC, AB and AC, AB. And what? Oh, it doesn't show it here. Sometimes it kind of shows you the lengths right here. Looks like I measured something twice. Oh, it's just saying what the lengths are. Never mind. So AC is 2.66. 2.66. Angle AC is 3.95. 3.95. Angle A, again, since it's a triangle, I know which angle you're talking about. Angle A is 98. All right, so that's cool. And now it wants you to do all this stuff. So in a different part of the grid, we're going to do a new line segment with the same size of question one. I'm going to go here. I'm going to make a line segment with the given length because I want it to be the same length. So line segment, given length. I'm going to do it here. And I want the length to be 2.66. Enter. Cool. I am going to move this so it kind of looks the same. It doesn't have to be. It'll just need more rotation. In fact, I'm going to try to do this one a little differently. I'm going to make it look a little different. Close enough to where I know that this corresponds with my A and this corresponds with my B, but far enough for you guys to see more on how to kind of rotate. Hopefully it doesn't take me that long to guess. At one of the endpoints of the segments, create a angle. So we're going to want to make this angle. So I want to make this angle, the A. And I want it to be counterclockwise. So that's always a good thing to kind of measure or decide right off the bat if we're doing counterclockwise. So here, I'm going to do given size. So I'm going to go from E to D. I want to do this counterclockwise, which it already is, and it's 98.06. And I can already tell I'm going to have to move this a little bit so I'm going to be able to see this. You'll see that it still wants the ray to be the same. So we want to make a ray here to here. All right, and the next thing it wants us to do, once you've created the angle included in the ray, draw right through it. So I already did that part. Identify the line segment question 3. So it's what it means by identify, just saying that I want this to be my CE. So I want to go from here to make a CE. So what I'm going to do, then place a point in the intersection. Wait, intersection? What intersection? Identify the other segment in that. E equal to identify. One way to do this is draw a circle. Oh, I see what it's saying. So there's a few ways to do it. I was going to do a line segment with a given length, but what they're saying is use a compass for it. So what we're going to do is we're going to do a circle with a given radius, and that radius is going to be whatever our AC was. So I'm going to do 3.95. Boom. So what this tells me is D to any point in the circle is 3.95. But since I want the angle to be the same, I want it to be on this line. So I want the distance to be 3.95, which is this circle, but I want that angle to be the same. So what I'm going to do is I'm going to mark a point right here. So I'm going to go to point, mark it right here at this point of intersection. And then from here, what I'm going to do is I'm going to make this a polygon. I'm going to go here, 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 and here. And now I have a nice polygon. So I don't want to look at this circle. So what I can do if I want to hide it, I can go to conics. Conics are your circles, your ovals, all of that. I'm going to hide it, and I can still see my shape. Had I not done the polygon, the point F would have disappeared because the circle was gone. All right, so we did that. Now we have these triangle, this polygon. So now I want to export my image. Share first. Share. It's going to be question 2. Name or whatever. Copy it. After it saves. What is going on here? I don't know why it's having such a hard trouble. Online mode failed. Oh, my internet's acting weird. There we go. So I'm going to copy that. Here. And again, if you want to do your image, you can export your image, download it. Your name, the name of the image is going to be the same as whatever you named it the first time. That's why you want to make sure this name is different than the first one you saved. And I think you could even do something like this. Mine is kind of cool. What it does is it saves it here. So instead of me having to look for it like I did with the first one, I can literally grab this and put it in here. So you can search for it by the computer, or if you're lucky enough to have this saved here, you can just drag it and move it over. Don't forget to click submit because I know Edmentum keeps logging people off. So now we want to map them onto each other. So what I'm going to do here, I'm going to map these onto each other. So I am going to match up my A and my D. So I'm going to do this, translate by vector, match up the A and the D as best I can. That's pretty good. And then I want to rotate. So I'm going to go here, rotate. There it is. Rotate about point. I really wish there was a way you can kind of play with this a little bit. So I'm going to rotate the shape about this point. And I want it to go clockwise. So let me go clockwise. I'm going to guess about 90 degrees. Let's see how far I am from this. Nope, too far. So let's try something kind of in the middle. So I'm going to try like 40 degrees. So it's already on that rotate. That's why I'm just able to do this. Let's try 45 degrees. Do it clockwise. Little bit more. I need a little bit more than that. Oh, I did it the wrong way. I guess this is a good way of you guys seeing what not to do. So make sure clockwise. Let's try 50. A little bit more than that. So 55. Make sure it's on clockwise. I hate how this board pops up. Little bit more. 57. And of course, I didn't do clockwise. Well, you guys get the idea. I know we're running out of time. Sorry about that. Is this making sense though? It's going to be a lot of trial and error. But do you guys get what you have to do here? Translate. So point D overlaps point A. Rotate about point A. And whatever degree you did it. So do they correspond? So this is pretty much going to be the same as before. They want you to put the picture of them corresponding. So since we're running low on time, I'm not going to do that, but it's pretty much the same thing as before. What does this tell you? Or what does this mean since they can overlap? So they do overlap. You're going to say that because you can do rigid motion, that means that two shapes are congruent. What does this mean about all shapes? Well, that means that anything with two congruent sides and an included congruent angle to another triangle means that they're congruent. So again, like I said, that's very similar, except now you're talking about congruent sides with an included angle instead of congruent angles with an included side. All right, and then let me see if I have enough time to do the last activity. So this is the explanation of it, that these two have to be congruent. So our question is going to obviously relate to this. So if this is congruent to this, what other fact do we need? So if we're saying that angle A and angle D are congruent, what other fact do we need? So we can also say that AC has to be congruent, or we can say that angle B is congruent to angle D, because that would correspond. So that one's there. And notice what? Oh, they want it side side. I did not read this part. I don't know why they would put another one, because technically, if this was congruent to that, angle side angle would apply. So they tricked me on that one. But this is talking about side angle side. So we want AC to be congruent to DF. So this one. Because they were talking about side angle side. All right, so now we're going to talk about side, side, side. This one's pretty obvious, but one thing you might not realize is that there's only one option for this. I'm not going to fill this out because apparently that's taking too much time, but you guys know what to do here. AC, AB, and BC, and then put the links. I'm just going to do the actual GeoGebra part because I feel that's the part you guys struggle with the most. It's actually the hardest part if you've never used GeoGebra before. I'm going to make my polygon. And then what I'm going to do is I need to follow these instructions. So they want, oh, I forgot to do the lengths. Measuring the lengths. If I follow the instructions, I've already done this before, but we want to draw another line segment the same length. So we're going to do line segment with a given length. And I'm going to make that length 4.76. So this AB is congruent to that. Now it wants us to do, we're basically just going to do circles, which is the cool part about this. I'm going to close this one. I don't need it anymore. The cool part about this is to measure this perfectly to get this point C, we need from point D to be 49 or 4.9 to get this length right here. And then from point D or point E, we need it to be 4 point that. So we need two things to happen. We need a line that's equal to this and another line that's equal to this, but we need them to touch each other. So the way we do that to make sure that these lines are there, instead of doing something weird like making these lines and then we have to pivot them ourselves, so move these around ourselves, like grab this. Let me use my laser. So grab this spot right here and move it around. And grab this spot and move it around. We're just going to use circles because circles have a given radius. So what I'm going to do here is I'm going to do circle with a given radius from point D, which is our point A. And I'm going to say it is 4.9 away from point C. And then from here, what I'm going to do is I'm going to do another one at point E, which is again is the same as our point B, and it's 4.22 away from point C. So I'm going to say this is, how far away is it? 4.22. So now this creates two spots, one here and one here. We only need one, so I'm just going to mark one of them to make our triangle. But the cool part about this method is you can also make another triangle up here. Another triangle up here that would also be congruent. So now that I have 3 points, I'm going to make my polygon. And this triangle should theoretically be the same as this. So again, what you're going to have to do is you're going to have to translate this D to point A and start guessing a rotation. So we've already done that a few times in this lesson. So I'm not going to do that, especially because we're out of time. Does this make sense though, guys, how we were able to do this? Do you guys understand why the circles are the best way to do the lengths? Now's a good time to ask if you don't understand why we're using circles. Everybody good? Hello? Anybody? Okay. Yeah, that's fine. I'll try to have this up like as soon as possible. But um, just so I can state it again, is a circle is this radius going all the way around. So by using circles, that's what lets us go like, oh, I want this length and this length to be equal. And then later on, if you guys need help, make an appointment with me on how to translate this over and how to rotate it if you guys still need help with that. But the main idea is that side, side, side is going to be the same. So that's all these activities are very similar to each other. I just spent a little too much time kind of describing why. So again, rewatch it so you guys can see how to answer number 5 and 4. The only difference is we're going to be talking about side, side, side instead of side, angle, side, or instead of angle, side, angle. So the wording changes a little bit, but the idea is still the same. So if we look here, this just says if two triangles have all corresponding congruent sides, So this side corresponds with this side corresponds with that side corresponds with that, and they're all congruent, the triangles are congruent. That means you can make them the same thing. So this is saying, what does X have to be for this to be congruent? Well, I know that these are congruent to each other. I know that these have to be congruent to each other, obviously, because they're the same line. So that means X plus 12 equals 2X minus 6. So we're going to have to use some algebra here, guys. So we have to take away the X, take away the X. 12 equals X minus 6. And then we're going to add 6 to both sides. So this tells me that X has to be equal to 18. So our answer is going to be 18 for this. All right. And as always, guys, just make an appointment with me if you need help reviewing this. This one, I think I underestimated how long these were going to take. So I took my time with some of them that I didn't need to. But this is the main ideas that we have to learn from this lesson. Just make sure you get those activities done. So again, guys, the question for today was, what was your favorite game? Board game, card game, whatever. I said Tony Hawk. So make sure to answer that before you leave. No problem. See you guys later. See ya. Late. Yeah, I saw that. I'm like, oh, he's definitely gonna have to rewatch it because I'm like, we did 3 activities, and you saw the last one where I skipped